Hi everyone. So today we're going to talk about objective 1.2, which is about identifying the domain and range of a relation given graphs. So we're going to be focusing on graphs today. Okay, yesterday we focused on, or on 1.1, we focused on relations given mappings and coordinates of points. Okay, but today we're going to talk about graphs. Okay, so let's take a look at the do now, which is a review of 1.1. The relation defined by the set of ordered pairs is a function. Now, why is it a function? Because the x's do not repeat. Which of the following ordered pairs would, if added to the set, result in a relation that is no longer a function? Explain. So we need to look for one where we have an x value that is 1, 2, 3, or 5. So if I added this to the relation, it would be a function because my x's wouldn't repeat. Okay, if I added b to the relation, 6 is my x, so that would still be a function. Now, if I added c, I already have a 2 in my set, as an x value in my ordered pairs, right? So my answer is c. Okay, and the reason is because x's would repeat. Or you can write each input would have more than one output. Okay, so relations can be plotted on a coordinate plane. So we're going to be talking about graphs, okay, where the domain is represented by the x-axis, or on the x-axis, and the range is represented on the y-axis. Okay, so today we're going to be focusing on the domain and range of a relation using set builder notation. So how do I represent the domain of a function given a graph? Well, what I do is I write this squiggly bracket. So I'm going to write it above, kind of like how you guys can see it, x such that, and then we're going to write some kind of inequality, okay, to represent all x values, okay, and it's going to be inside these squiggly brackets. Kind of looks like a 3. I'm going to fix it so it looks like a squiggly bracket. Okay, so range is the same thing. Y such that, except it's y such that, and then an inequality to represent all y values. Okay, so that line means such that. So if I ever say such that and I draw a line, that's what I mean. Okay, and we're going to talk about that in a minute. Now, when given a graph, the vertical line test can determine whether the relation shows a function or not. In the vertical line test, if each vertical line is drawn through the graph intersects at only one location, then the graph is a function. Okay? If each vertical line is drawn through the graph intersects at only one location, then the graph is a function. Okay? So basically, if I draw a vertical line and it passes through the graph more than one time, it's not a function. So I'm going to show you what I mean by that in a second. Okay? So let's take a look at an example. Okay, on the top here we have example number 1. We have a straight line and we're asking for the domain, we're asking for the range. So the domain is the set of all of our x values that are included in this graph. Now this graph has an arrow on both ends. So this means that this graph is going on forever and ever and ever in this direction and forever and ever and ever in this direction. So that means that my domain is actually going to be all real numbers. Okay? Every single x value is going to be on this graph or represented on this graph. Same thing with my range, all real numbers. All right, the reason for that is again because my y values, okay, my arrow means that I'm going on forever and ever and ever. So my y values are going to get infinitesimally small and infinitesimally big. I'm not sure if I'm saying that right, but infinite, it's going to go all the way up to infinity and all the way down to infinity. Okay, so all real numbers are my range and my domain. Is this a function? If I drop a vertical line anywhere on this graph, it only hits my graph one time, so it is a function, yes. Okay, domain for this one, Now this one is interesting because I have an arrow going in this direction, which means it's going forever and ever and ever, and an arrow going in this direction, which means it's going forever and ever and ever, okay? Which means it never stops. So now my domain is going to be all real numbers. Okay, however, my range is not going to be all real numbers. I only have 1, 2 y values on my graph. I have no y values that are negative. Okay, if I take my pencil and I go up, 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 up on the y-axis, okay, I have no y values that are negative. My only 2 y values are 1 and 3. So my range is actually going to be y such that y equals 1 and y equals 3. You could write that with a comma. So I only have 2 y values on this graph, 1 and 3. Okay? Is this a function? The answer is no. Why? Because if I drop a vertical line right here, it's going to hit my graph twice on these two closed circles. Okay? This guy right here, domain, we have our smallest x value is -4, okay? And our largest x value, well, we don't have one because we're going up to infinity. So when we are asked for the domain, we need to find the smallest x value first and then the largest x value next. So I'm going to take my pencil and I'm going to go along the x-axis and I'm going to see, all right, what's my smallest x value? Well, it's -4. So I'm going to write my domain is x such that -4, okay? But now here we have all these are represented on my graph, and this arrow means I'm going on forever. Okay, so that means that I'm going to have any x value that is greater than -4. So -4 is less than x, or you can write x such that x is greater than -4. Okay, now be careful. We're not going to write greater than or equal to because this open circle means that this point is not included on my graph. Okay, now range. My smallest y value is 1. Okay, so I'm going to write y such that 1. Now, this arrow means it's going on forever and ever and ever. Okay, so I'm going to have any y value that is greater than 1 is going to be on my, or in my range. So any y value greater than 1, or I can write y such that y is greater than 1. Now, be careful here. My smallest y value has closed circles here, so that means that that is included on my graph. So I need to write greater than or equal to. So closed circle, that means greater than or equal to or less than or equal to. And I said that backwards. This is less than or equal to, this is greater than or equal to. Open circle means just greater than or just less than. Okay, just less than or just greater than. Okay, now is this a function? If I drop a vertical line on anywhere on these graphs, it's only going to pass through my graph one time, so yes, indeed, it is a function. Okay, so let's do a couple more. Number 1, my domain. First thing I need to do is find my smallest x value. So I'm going to go along the x-axis, and I'm going to say, all right, my smallest x value is right here. It's -1, 2, 3, 4, 5, 6. -6 is my smallest x value that's contained on my graph. Okay, so my domain is going to be x such that -6. Okay, and then my largest x value is going to be here. So it's 1, 2, 3, 4, 5, 6. So -6 is less than or equal to x, which is less than or equal to 6. Okay, so basically you're going to write your smallest x value, then your largest x value, and it's going to be separated by these inequality symbols and your variable x. Please be careful, okay? Our domain is the smallest x value that is included in my graph or on my graph. So don't say that this is -8, it's on my axis, that's my smallest x value. My graph doesn't go over here, okay? So that is not my smallest x value. My smallest x value is the x value where my graph starts, the smallest x value contained on the graph. Okay, range. My range is going to be y such that, well, my smallest y value, I'm going to go up or down to up. So my smallest y value is right here. That's 0. Okay, so 0 less than or equal to my largest y value, 1, 2, 3, 4, 5, 6. So less than or equal to y, which is less than or equal to 6. Is that a function? If I drop vertical lines on this graph, it's only going to pass through it one time, so it is indeed a function. Okay. Number 2, my domain. My smallest x value is right here. Whenever I'm asked for my domain, I like to take my pencil and go, starting from the left, go right. Stop at the leftmost point on your graph. The leftmost point on my graph is right here. That's negative 1, 2, 3, 4, 5, 6, 7. Or negative 7, right? Less than or equal to x, which is less than my largest x value. If I'm going with my pencil right, stop. It's going to be 1, 2, 3, 4, 5. Okay. However, I have an open circle here, so I'm going to leave this just less than, not less than or equal to. Alrighty, now range. I'm going to go down to up with my pencil. So I'm going to go up, 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 stop. My smallest y value is right here. My smallest y value is negative 1, 2, 3. Okay, so notice I have a closed circle at when my y is negative 3. Okay, and then I'm going to go up, 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 stop. My largest y value is 1. So negative 3 is less than or equal to y, which is less than 1. Just less than, not less than or equal to, because I have an open circle. Okay, is this a function? If I drop a vertical line anywhere on my graph, it's only going to hit it one time, so it is indeed a function. Okay. All right, number 3, domain. Now, this is interesting because my domain, if I go right, stop, my smallest x value is 0. Okay. Now, I have any x value that is greater than 0 represented on my graph. So my domain is going to be x such that x is greater than or equal to 0. Okay. Any x value greater than 0 is going to be contained on my graph. Range. My range, if I go down to up, you might think, wait a minute, my smallest y value is right here, but be careful. This arrow means I go on forever and ever and ever and ever. So my range is going to be infinitely small and infinitely big. So my range is all real numbers. Okay? All real numbers. Now, is this a function? No, it is not. If I drop a vertical line anywhere on my graph, it's going to hit it twice. Well, not anywhere. If I drop it here once, it's only going to... If I drop it here, it's only going to hit it once. But if I drop it any other point on my graph, it's going to hit my function twice. So if I drop it right here, it's going to hit it 1 time, 2 times, so it's not a function. Okay? Number 4 looks kind of similar to 3, except here, my domain is going to be all real numbers. And the reason for that is because these arrows mean it's going on forever and ever and ever, and forever and ever ever in this direction as well. So that means that I don't have a smallest x value, or I don't have a smallest y value. Okay, my range, if I go down to up, my smallest y value is 0, and my largest y value is, well, I don't have one because it's going on forever. So my range is going to be y such that y is greater than or equal to 0. Okay. And yes, this is indeed a function. If I drop a vertical line anywhere on my graph, it's only going to hit it 1 time. Okay. Domain for number 4. This one is interesting. It's just a vertical line. I'm going to go left to right, right, stop. I only have one x value on my graph. So I have negative 1, 2, 3, 4, 5. So my domain is just x equals negative 5. That's my only x value that is represented on this graph. X is equal to negative 5. Okay, my range, well, I'm going to go down to up. So I'm going to go up, 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 stop. My smallest x value is negative 2. So my range is going to be y such that negative 2 is less than y. Be careful. We are not less than or equal to because we have an open circle. And then I'm going to go up, 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 stop. And my biggest y value is 1, 2, 3, 4, 5, 6. Just less than because I have an open circle. Okay? Is this a function? No, it is not. If I put a vertical line here, it's going to hit my graph infinitely many times, right? It is a vertical line, so it can't be a function. No. Okay? Last but not least, number 6, domain. Okay? If I go starting left, do I have my smallest x value here? Not yet, so I'm going to keep going, stop. Right here, my smallest x value is 0. Okay? That's the first spot on my x. That's the rightmost spot on my graph for x. So my domain is going to be x such that, okay? Now I have any x value that is greater than 0. So it's going to be x is greater than 0, but not greater than or equal to, because this is an open circle. Okay, my range is going to be y such that I'm going to go down to up, because my smallest y value is not down here. It's not up here. Not yet, stop. I only have one y value. So the only y value I have here is 1, 2, 3, 4. Y equals 4. Okay, is this a function? If I drop a vertical line anywhere on this graph, it's only going to hit it one time. So yes, indeed, it is a function. Okay, so ladies and gentlemen, that was a review from Algebra 1, domain and range of a graph. If you have any questions, as always, please feel free to reach out. I hope you all have a wonderful day, and I will see you soon.